In this segment, I am going to graph the function y equals cosine 2x. Okay, so we haven't looked at anything yet where I have some constant that I multiply by x. Remember, x is the angle, right? So what happens if I multiply the angle by 2? So I'm going to let this chart help me out. Okay, so remember the angle is x, right? And so this is the x and y chart for, the first line here would be for cosine, right? So, you know, cosine of 0 is 1, cosine of pi over 2 is 0, and so on. Okay, so I'm going to make a chart where, you know, this is my x value, but I'm going to have a separate line for 2x. All right, because what I've done here is I've multiplied the x by 2, then I'm going to find the cosine in the last line, then I'm going to find the cosine of 2x. Okay, and just to make life a little simpler, I'm going to start here and just look at this half of the graph because that's enough to see what's going to happen here. So take my x, multiply it by 2. So x is 0, multiply it by 2, I still have 0. Pi over 2, multiply it by 2, I get pi. Okay. Multiply pi by 2, I get 2 pi. Then I'm going to have 3 pi and 4 pi. So if I said, okay, here's my 2x, right? So now cosine of 0, right? Because this is what I'm finding cosine of. So use the line above here in blue to help us, right? Cosine of 0 is 1. Cosine of pi is -1. But see how now this value occurs at pi over 2, right? Rather than occurring at pi, it's occurring at pi over 2, right? Because I've multiplied the x by 2. And then cosine of 2 pi is 1. And so remember what we said about a full cycle of cosine, right? A full cycle of cosine is when cosine goes from 1 back to 1. All right, so what we should be able to see here is that we get a full cycle of cosine in half the time, right? There's a full cycle, okay? And so this takes me around the circle again, right? Now I've gone around the circle. This would be the same value because 3 pi would be the same as this, right? Because I'm halfway around the circle again, right? And then this is just twice around the circle. Okay, so here I'd be back at -1. Here I'd be at 1. So what I notice when I multiply by 2 is it speeds it up, right? So if my original cosine curve, let me draw the original curve here in green, okay? My original cosine curve looks like this, right? I get 1 cycle from 0 to 2 pi, right? But now I have 2 cycles from 0 to 2 pi. Or in other words, I got 1 cycle in half the time, okay? 1 cycle in half the time meant I got a cycle in pi rather than in 2 pi. Okay, so let's fill in some definitions here, some important words. The period of a trigonometric function, okay? And the period is the length of the interval needed, or the amount of time, or I've also seen it written like the horizontal distance, the length of the interval needed for one complete cycle of the graph. Okay, so the period is the amount of time it takes to complete one cycle. You might hear that and say, gosh, that sounds a little bit like my middle school health class, right? Not a coincidence. Okay, a period is the time it takes to complete a full cycle. So the frequency of the trigonometric graph then is the number of complete cycles in 2 pi units. Okay, so how many cycles can I complete in 2 pi units? So for this function that we just graphed, y equals cosine of 2x, in this case, the period of the graph, I'm going to call it p, the period would be pi, and then the frequency would be 2. Right, I got 2 full cycles from 0 to 2 pi, or it took me pi to get 1 full cycle. I'm going to let you on Kirk's video. He does, I think, a really good job explaining the formula. And then I just want to point out, if I were to keep going here in red, I just want to point out that this would keep going like this, right? Because we've been graphing all of these from negative 2 pi to 2 pi. So this would keep going if I filled it in here out to negative 2 pi. So let's come to this other grid and let's take a look at graphing the function y equals half, sine half x. Okay, and so if you're good at recognizing patterns, you might say, you might be able to think ahead to what the frequency and period would be here, right? If 2x made me get 2 cycles between 0 and 2 pi, what do you think sine of a half x is going to do? Okay, so if you're good at recognizing structure in repeated reasoning is what that's called, where you can take one example and kind of extend that idea to another example. That's what that's referred to, structure in repeated reasoning. That's an educational word. But like I said, that's my niche here at the college. I work with the education students, so that's something I talk to them about. But to be a good math student, it's important to be able to recognize and extend patterns, right? That's part of being a good mathematician. So anyway, if this is x, then I'm going to make a line for half x, and I'm going to do the same thing I did last time, where I'm going to kind of focus from 0 over and look at just what's happening between 0 and 2 pi. So half x, half of 0 is 0. Half of pi over 2 would be pi over 4. That's one of the ones I wanted you to memorize, right? Sine of pi over 4, that's 45 degrees. And I really wish I didn't have to make all your quizzes open notes, because I would quiz you on all of these and make sure you knew them. But that's radical 2 over 2, which is about 0.7. Okay, if I changed it to a decimal. So anyway, let's see, half of pi, pi over 2. Half of this would be 3 pi over 4. So last week we learned how to find sine of 3 pi over 4, right? That would have a 45-degree reference angle. It would be in the second quadrant because it's 135 degrees. It's, y is positive over here in the second quadrant, so it would still be positive. It would have the same reference angle, right? The 45-degree reference angle, and so it would have the same value of sine, all right? And then this would be pi, Okay, so if I look up here at the values in red, sine of 0 is 0. Sine of pi over 4, so I just mentioned that, that's 0.7. Now, sine of pi over 2 is 1, but notice now, instead of the 1 occurring at pi over 2, the 1 now occurs at pi. Okay, and like I just said, these two have the same reference angle, right? Therefore, the sine value is the same, and then sine of pi is 0. Okay, so remember a full cycle of sine, right? I'll come over here and draw the full cycle of sine. I have to go this upper hump, this lower hump, back to 0 to get a full cycle of sine. And what we can see happening here is that I got just that upper hump, right? So I only got half of the sine curve from 0 to 2 pi, okay? I would have to extend this line out, and it won't let me go over far enough, and I would get my full cycle of pi if I could keep going out to 4 pi, but I run off my page. But I could go like this and show you that here's my other half. Okay. So we should not be surprised that we got half of a cycle of sine from 0 to 2 pi. And it would have taken me 4 pi to get a complete cycle of this. All right, so the period here would be 4 pi. And the frequency for this graph is a half. I only got a half of a cycle from 0 to 2 pi. So I'm going to let Kirk do some of the other explaining of this with you.